And thank you for the opportunity to be here and present our solution. Just a few slides about VEO, because I guess you are not so familiar where Finland is even placed. Yeah, this is our slogan, rethinking the current. That's what we are doing. And the field we are working in is about electrification and automation. That is our field. A little bit of figures where we are located for sure. Here is our headquarters, yeah, there. And the region we are working in is the Nordic countries. So we are basically handling Sweden, Norway, and Finland as our areas. We also have a subsidiary in UK, but they are dealing with a little bit of the other stuff. We are about 500 people, a lot of engineers, and from that part, about 50 of software people working with different solutions. Our segment where we are working so is basically this. It's a lot about energy and distribution. So we are dealing with hydropower, process industry, data centers, wind power, energy storage, solid power. We have connected about 7 gigawatt of wind power in the Nordic countries to the grid. So a lot of that. Also, if you go on some nice ferry in the Caribbean, so all the luxury cruises which are touring there, so the low voltage switchgear inside that vessels are built by us. It's about 350 meters of low voltage switchgears inside those cruisers. Yeah, as I said, hydropower has been the core of VEO since the founding, since in 89, and also a lot of, let's say, business together with Wärtsilä, which is one of the big players in Finland, doing generators and supplying the world with electricity. So onto our product with WinCC OA then. As said, our clients are the Nordic energy and power grid owners. Coming back to our, let's say, message here is maybe that we started a project and basically we ended up with a library. That's maybe the story. So our journey with WinCC OA started in 2016, where we did some power plant deliveries. Also, as said, we are delivering to parts of world where maybe Microsoft is not the allowed stuff to be delivered. So also utilizing WinCC OA possibilities to be driven on different operating system was something that interested us when we started our OA journey. So we have delivered several power plants built on the Linux platform. And 2019 we did our, let's say, first large-scale project, which is over 100,000 tags. Also utilizing APM and distributed technique there. That is actually the factory where they make the Wärtsilä engines in Vaasa. After that, we went on to the project I am going to talk about. And how did we succeed to win that? I think one of the biggest reasons was that we were approached by a client who wanted to find not only a traditional SCADA, where you, let's say, visualize things and you run your stuff and so on. The customer has several different assets. He owns hydropowers, he owns wind power parks, he owns solar parks, and he wanted to combine all these into one place. And really find not only a SCADA solution where operators, let's say, monitor and so on, but also a data platform which they can utilize in the future. And that is maybe, let's say, driving on what Walter also talked about. WinCC OA is really a data platform that can contribute and deliver, let's say, also northbound communication in a good way. So we started that in 2022. We are in first SAT stage in that project at the moment. Will be a large-scale distributed system, over 500,000 tags in the system. And currently, as I said, we have come to the conclusion that we actually created a library. So a little bit of how this is built up. said, we have a data center where the main system is running, and also, let's say then, distributed assets on the hydropower stations and solar parks and wind parks. This will grow in the future with more wind parks, more solar parks, battery applications, and so on. So we are really building on this. And our goal is to create a library controlling all this and be able to handle this type of processes. What is, let's say, challenge, of course, is these are all brownfield, the hydropower stations. The data is not in a structured way in any way, so it was a must to make a, let's say, distributed solution here to really collect the data locally and also be able to run the power plants locally. And also then, of course, these wind parks are, part of them are brownfields and part of them will be greenfields, because we will expand with 3 more wind parks here in the autumn, and a lot of solar parks also will be connected in the future. So this will really be a platform for the, let's say, our customer to build on in the future. Basically, we have come up with 2 different ways of handling the user interface, which of course is one part of this. We have a, let's say, a floating window here where the customer can build his own process views, especially in factories where you have, let's say, a process and also, let's say, electrical distribution, which is our doing often. So then this has been a quite good solution that the operator can create his own views, save them, and call them back when he log in. Then into the more, let's say, standard way, which we will be using probably for the hydropower and other assets. This is based on ISE standard, or ISA standard, sorry. And also, let's say, on the philosophy of how to display and how to build this. And of course, situation awareness and bright colors used only to draw attention, otherwise they are quite dull, these pictures or screens. We are, of course, also capable of, let's say, specifying how you should dimension your system, especially if you run on a data center, what you would require for resources to do this. Yeah, forgot to mention that the technique we are using here, we started with 319. So, and we made the decision right from the start to go with Postgre as the database, and also, let's say, a heavily distributed idea how to do the database collection. We have one main database on the central system, but also on the locally there are Postgre databases, and this has maybe been one of the biggest challenge and biggest learning curve to work with the Postgre and get everything collected and working with distributed solutions. Yeah. Of course, when we try to sell a library and do everything about that, we are also focusing that we can provide a lifecycle offering for the library and also for, all, let's say, all the deliveries we deliver from our factory. So pretty much focus on that also, and we have the Cyber Resilience Act, which will be one of the important topics here also. I'm very looking forward to that, and I think there we also have a role to play in the future. So a little bit onto the library. Oh, this was a nice picture. Not very good, but anyway. This is the building blocks we have made for this. Cannot be good shown here for some reason. But anyway, if you jump onto the frame contents, so it's about screen navigation, user handling, area of responsibility, which is of course of great importance when you're operating different assets, as in this case. Alarm event and trending is 2 most important tools for the operators here. And also we created the shelving, which is one of the things that currently is not existing, but still exists in some way. Yeah, so this was our interpretation of the shelving function. So we are able to set the alarm to out of service and shift times and so on, which is sometimes important for the operators, how you can show the alarms. Also one, let's say, peculiar thing, there's a great map function inside the WinCC OA, but how you do that in a closed system? Because if you gather the OpenStreetMap, it's a huge file, and it's not possible to run in the system we are running it in currently. So then we come up with, okay, we use tiles and try to get down the file a little bit, and it works. It has details enough for the, let's say, maintenance personnel also to be able to guide them to the correct place when doing maintenance. So this was one of the things we find out and solved in some way. Also, creating alarms on the fly was one of the things. For the wind park PPCs and so on, they do not have a really good OPC UA interface, especially the ones we have run into so far. So then we needed to find a solution. How do we solve this? So basically, they have an alarm and event database, which we poll. And then, of course, check it's a new alarm. If it's a new alarm, we create an alarm on the fly and activate it and so on. So also a lot of scripting and let's say doing around that. And maybe that is what we stand for. We try to find a solution. This is more or less a similar normal object graph, is just combining operator limits and process limits, because, as I said, we have brownfields and we have, let's say, also, we need to have the possibility also to do alarms with the SCADA, not only coming from the process, so we combine that in a way. And also, I noticed that somebody talked about rate of change and so on, so that is also one thing that is included here. So, our automation and electrification solutions can be found in over 130 countries already, and just thank you for the opportunity to present our solution.